But what I will be speaking about would be data science for the rest of us. So if you're a developer, could you please raise your hand if you think of yourself more of a developer? Okay, so we have a lot of developers here. How about any data scientists? Any data scientists? Okay, good, good. So we have some data scientists. But this talk is really for helping you think about data science. How does a data scientist think? How do you use data? And then that will help you be able to create a solution that uses data. So, in summary, data science is not magic. You know, sometimes if we don't understand a topic, sometimes we just think it's magic. But really, data science is not magic. But there are some tricks and secrets that might be interesting to think about. So the 4 main points that I'll be covering today in terms of the secrets for data scientists. First is to know your data. It's very important that you have to know your data. Second, know your question. What question are you asking? Know your domain, because you are experts. You know your data. Know the domain of your data, and know how you're going to use the answer. Because sometimes people go and they have a problem and they ask things and they don't even know what they're going to do with the solution. So know how you're going to use your answer. So the first thing that we're going to talk about is know your data. So let's say you wanted to make a pizza, right? Let's say you want to make a pizza. What are some of the things that you need to make a pizza? You probably need flour. You need water, you need cheese, maybe spaghetti, tomato sauce. You know, you need good ingredients, and you need relevant ingredients. The data, just like data, if you don't have the right ingredients, you will not have the right product. So you need data that's relevant, it's connected, it's accurate, and you need enough data. So let's talk about blood alcohol content. So basically, let's try to predict whether somebody is drunk. Okay? How do you predict whether someone is drunk? So irrelevant data on the left here is, let's say your data is the price of milk per gallon, or like the Red Sox batting average. Like, that's not very useful. If you have data like that, you're not going to predict somebody's blood alcohol content, right? But how would you? Okay, maybe in terms of their body mass, if you know how much they weigh, if you know how many alcoholic drinks, margaritas they've drunk, then maybe there's an easier way to be able to predict their blood alcohol content. So it's very, very important to have the relevant data. Sometimes you'll find that data is very disconnected. Maybe you have a data source that's about one thing, and you have another set of data that's from something else. You try to join them together, and you find you have a lot of missing pieces. So in this case, you have a lot of disconnected data. You're trying to predict how good a burger is, but sometimes you have the weight of how much that beef weighs. Sometimes you have the grill temperature. But without those 2 components together, you're not going to be able to get a good rating. And so you need to have the good connected data. And there are some ways of processing data if you're missing some data. But again, it's very important to have connected data. So now let's say you have some data, but maybe it's inaccurate. So if it's inaccurate, it's not very useful. So you need accurate data, but not only it's accurate, but it's also precise. So you have to think about the difference between precision and accuracy. So in this case, here on the left, this is very precise data. Like, all the data is close together, but it's not very accurate, right? The accurate data is the one that's precise and it's accurate. But sometimes you might have data that has a bias. That the data maybe is not close to where you want it to be. So you have to make sure you have accurate data. And you also want to make sure you have enough data. So let's say I came to you and said, hey, let's go on a vacation. Do you want to come with me on a vacation? This is where we're going. Okay? So can you make a decision? I say, hey, let's go. Who wants to go? You don't have enough data to make a decision. So it's not very useful. Maybe you have enough data, okay? So now you're starting to see. So sometimes enough data helps you make a better decision, but you want to make sure you have enough data. So now you see something like this, and I say, hey, let's go there for a vacation. Now you can make a decision as to whether you do want to go here or not because you have enough data. The next step is know your question. So a lot of times, maybe you have bosses, or maybe you're a boss, and you ask very vague questions, questions that are very hard to answer. So vague questions cannot be answered with a name or a number. So let's say your boss can say, tell me about the business. How do I respond? Or what should I do? Maybe your boss comes to you and says, what do I do? And how do you answer that question? Or how can I increase my profits? Right? Very unclear, vague questions. And so you want to make sure you have very sharp questions. Sharp questions can be answered with a name or a number. So make sure the question that you ask can be answered with a name or a number, such as how many of these items, these Model Q items, can I sell in Taipei in the next third quarter, right? So that's a number you can answer with. Or which car in my fleet is going to break down first? That is a specific car, a specific answer. So make sure you ask a very good question. And the types of questions that you ask will then determine what algorithm you're going to use. So maybe you're asking a question about how much or how many, or you're asking a question about which category or which groups. Maybe your question is something strange, or even choose an option. So depending on the question that you're going to ask, that will determine the algorithm that you're going to use. So the first category is how much, how many. So what will the temperature be next Tuesday, right? That's a how much, how many question. Or what will my fourth quarter sales in Portugal be? That's another one of these questions. Or how many new followers will I get on Facebook or Twitter next week, right? These questions can be answered with essentially a number. And so these are called regression type problems. And so there are specific algorithms that help you calculate, and these are regression problems. The next type for classification is which category. So let's say I had this picture here. And so is this a picture of a cat or a dog? Right? So there's categories. I have a category of cats. I have a category of dogs. So this is a classification problem. Or which aircraft is causing this radar signature? Right? I get some radar information. What's that aircraft? And again, there's specific types of aircraft, and one of them is causing that aircraft signature, radar signature. Or what is the topic of this news article? Or if we want to do text analytics, what is the topic of this news article? So this is a classification problem. If you're asking questions like these, you would want to use a classification algorithm. The next set is which groups. So basically, when you're doing some clustering. So which shoppers like the same vegetables, right? So let's say you own a supermarket, or you're a Costco, and you have different types of customers who come in. Who are the ones who buy the carrots? Who are the ones who buy the celery? Who are the ones who buy different types of vegetables? If you can identify and cluster the different types of customers, then you can target them, and you can increase your sales that way. Or which people like the same kind of movies, right? So what are those types of people? Clustering. Or what is a natural way to break these documents into 5 topic groups? Again, you're clustering things, the same things that come together. Another type of algorithm is called anomaly detection. So this answers the question of, is this strange? Sometimes you just have lots and lots of data, and you're just trying to figure out if something is strange, right? So one example is maybe the temperature in the room. The temperature in the room is set at maybe 23 or 25 degrees, and it's 25, 25.1, 24.9, 25, 23. All of a sudden, it goes to 28, right? Then that's strange. You're expecting something around 25. So anomaly detection will help you find those anomalies. Or so let's say you have sensor data. We talk a lot about the Internet of Things. You're taking a lot of sensor data. So these algorithms will help you when it finds something strange. And so other types of questions such as, is this internet message typical? Or is this combination of purchases very different from the customer has made in the past? So your bank does something like this. So if you've ever had a credit card, and I don't know if you've ever got a call from your bank saying, oh, this is strange activity, right? Maybe all you do is you use your credit card, and the only thing you ever buy are vegetables. You only go to Costco, and that's what you use your credit card on. All of a sudden, today, you're buying an airline ticket, you're buying a hotel room, you're buying all these different things. Wow, that's kind of strange. So your bank is doing anomaly detection, finding something strange, and then informing you. So these are anomaly detection type problems. The other type is which option. So if you go into something like Amazon, if you go to a marketplace type website, then they can help you. Which product would I like? Or you go to something like Facebook. They have a lot of ads. Which ads would be useful to you? So these are recommendations. Or should I buy other items along with what I currently have? Or what movie should I watch next? These are recommendation type problems. The next thing is to know your domain. So as a data scientist, as someone who's working with data, if you just go look at a random database and you have no idea what that data is about, then that's not very useful. You can use a lot of algorithms, you can try to do a lot of things, but you know what? At the end of the day, you need to know your specific domain. So going back to knowing your data, you have to know your domain, but you have to know also how to correct for missing values. Because if, let's say you have a data set that collects data from elevator sensors. Right? So we work with a company called ThyssenKrupp, and they put sensors in their elevators, and we collect all that data to try to find out if their elevators are going to break down. So if you did not know this data came from elevators, then you won't know how to process the data. So what if you have some missing values? You need to know what kind of values you need to put in there. Collection flaws, maybe the data comes in, maybe you drop a few items and you don't know. How would you fix things like that? Feature dependence, leakage, misinterpretation, or feature engineering. So as I mentioned, sometimes from a predictive maintenance perspective, these are some of the questions that can be asked. For example, from an aerospace perspective, what is the likelihood of delay due to mechanical issues? Or utilities, when is my solar panel wind turbine going to fail from predictive maintenance? Or manufacturing, especially say like you're in the science park and you have a factory that you're making wafers out of. So when will some component break down? Or transportation, logistics. When is this bus going to arrive at a different place? So or when is this component going to break down on my bus? So lots of different use cases. So in terms of identifying some data sources, so let's say, again, this is just an example for predictive maintenance. So failure history. So let's say we have the history of data from within the machine. We have a repair history. We know when those machines were repaired. We have the machine conditions. So we're collecting data from the sensors. Also different features of the machine, operating conditions, operator attributes, etc. So you have all this data that you can work with. And this is more of an example for predictive maintenance, predicting when something will break. But you have all the data for yourselves that you are using today, whether it's data from your customers, data about your users, or anything that you're trying to predict. So feature engineering is basically creating features that provide better predictive power to the learning algorithm. So today, when I showed you the Titanic example, we had different types of features, right? To predict whether someone will survive the Titanic or not, we basically gave the passenger class, the age, whether they traveled with siblings or parents, how much they paid for their ticket, etc. Those are all examples of features, and we use those features to try to predict whether you survive or not. But you might want to combine some features, or you might want to do things with the features to try to make a more accurate prediction. And so that's essentially what feature engineering is all about. So some examples for feature engineering, you can do rolling aggregates. Basically, think about the last 5 minutes or the last 10 minutes or whatever, some window to be able to aggregate that. Lag features for the short term, pick a window and basically, again, create aggregated features, or long term, So you're trying to capture degradation over time. And so here's an example of two columns. So column 0 and column 1 are basically example data that we get from sensors. And we're trying to predict column 2. So if I were just to do a scatter plot of these two features, it's very difficult to try to predict column 2. And coefficient of determination here is just basically the predictive power, how good this is. And you can see here, it's not very good. OK, so let's try some feature engineering. Let's try to multiply the numbers together. So I multiply column 0 with column 1. 5 times 5 is around 25. With some additional numbers there, I get around 26. But it's still not very good. I'm not doing a very good job of predicting. And so this is where domain knowledge comes in. What if you knew that that column 0 and column 1 were just basically 2 periods of time in which I was getting data from sensors? Basically, it was sensor data that came at time 0 and then at time 5. Oh, OK, now this is very important. You have this domain knowledge. And you can say, well, this is just the difference in time from data. So I'll subtract these numbers from each other. And with that, you can see here that I get a lot of good predictive power. So again, that's why it's so important that you need to know your data very well. So as a developer, working with the people who know the data in your company, working with the people who are building the models, it's important to work together and understand what all this data is. So let's see, what can we do? So make sure if we wanted to do something, then we need to make sure that the question is a very sharp question. So example, let's predict whether this component will fail in the next Y days. The data measures what you care about. So at the level, identifiers at the level you're predicting, relevant data collected, everything that you care about is actually being collected. Make sure your data is accurate. So failures are really failures. Because sometimes you get data and you try to train a model, and the model is based on your data. So if your data is not very accurate, again, it's not going to be very useful. Make sure your data is connected, and so that you can join it easily. Again, a lot of people seem to work with databases. You can join them easily. The data is connected. Make sure you have a lot of data. And we talked about that this morning, too. If you wanted to build something that could predict where a face was or whether someone was male or female, you need lots and lots of data to be able to bring it all together. Something else to think about is know how you're going to use the answer. So we've spent a lot of time thinking about the data science process. So you're collecting your data, you're processing it, you're building a machine learning model for it. What are you going to do with the answer? You're going to get an output. What are you going to do? And so that will actually help you decide what kind of model you're going to use. For example, binary classification. So if you were trying to just predict either 0 or 1, then you might use a binary classification algorithm. So will something fail in the next 5 days or not? Yes or no, right? Binary classification. Will something fail in the next 5 days? Then if that's the question you're going to ask, and that's the answer that's what you're going to do with the answer, then you can use a binary classification algorithm. If you wanted to predict remaining useful life, so for example, I have an engine on my bus. So if I own a lot of buses, then I want to predict how long this engine will last before the engine breaks down. That's a regression problem. This will say this engine can survive for 10 more days, this engine can survive for 5 more days, etc. That's a regression problem. If I wanted to do multi-class classification, so basically a specific time period, so all the buses that will break down in the next week, in the next month, or the next year, right? So I have 3 different classes. And so those who will break down in the next week, I'm going to go fix today. Right? Those in the next month or the next year, then I don't need to worry about. I can fix a little later. So that means I would use a multi-class classification algorithm. Anomaly detection, again, is more of is something strange, identifying these trends. So in this case, I might even just collect sensor data from all the engines of my buses and try to figure out if something's strange. Everything's normal, that's great, but all of a sudden, maybe something is strange in one of the engines. Then I'll go and look at it a little bit more. And so this is just basically an example of the types of responses, the answers that you'll get. If you run a regression algorithm, that will just give you a set of numbers. So this is basically saying, how much longer before my engine breaks down? Is it 5 days? Is it 10 days? Is it 20 days? That's what it'll give you. If you do a binary classification, you can see here it's just basically zeros and ones. Will something fail in the next month or not? Basically 0 and 1. Or multi-class, basically 0, 1, 2. So something that will fail in the next week, next month, next year. Again, multi-class. So the data science process is basically, again, just a way of thinking about how you would go about doing data science. And so we'll make these slides available to you. But again, just kind of summarizing the things that we were talking about. The first thing is to define your objective. Again, what are you trying to accomplish? Define your objective. That is very important because sometimes maybe as developers, you like to just start coding or you just like to try different things. What are you working towards? What's your objective? This is very important. Define your objective. Second, access and understand the data. Do you even have the right data? How can you make a prediction about something if you don't even have the right data? Third, data pre-processing. And then you just start doing the historical data. So again, just like the Titanic example I showed this morning, we had the passengers from the Titanic. We understood that this is the characteristics of the passengers. We understood whether they survived or not. We did some pre-processing, and then we understood, we knew which ones survived and which ones did not. We did the split, so we had our training data and our test data. So it's very important that you keep some data that you don't use when you're training your model, because that's essentially like cheating. Because if I had used all the data and I trained my model on it, then it would be very accurate on that data. Right? It would be very accurate. If I take anything from the data that I used to train and I run it through my model, it'll give me very accurate predictions. But if I take something that I've never seen before and I try to run it through the model, then those predictions may not be very good. So that's why it's very important that you save some data that you test on as you're building your algorithms. And so you're training, you're scoring, evaluating. And so these are just basically the building blocks. And tomorrow at the Azure Machine Learning tutorial session, we'll be doing this together. So bring your laptops, and then we'll go through this step by step of how do you build a machine learning model. And so there are lots of ways of doing this. So we have something online called the Microsoft Azure Machine Learning Algorithm Cheat Sheet. And so we'll make the URL available for you so that you can download this. But basically it says, if you have a question, what algorithm should you use? Do you have a binary classification question? Do you have a regression question? Do you have a multi-class classification question? This will help you pick the right algorithm. Because when you're using a tool like Azure Machine Learning, and it says, do you want to use logistic regression? Do you want to use clustering? Do you want to use support vector machine? What do you choose? This will help you at least choose something that might make more sense. So you could build this yourself, or the other question is you can make other people do your work for you, right? So that's probably one of the easier ways of doing this. So I'm going to do a quick demo on something else that we're predicting. And so let me go to Azure Machine Learning. Okay, so let's take a quick look at the data. So I'm just going to open up a sample experiment. Very similar to the Titanic experiment, again, using Azure Machine Learning. Seth, in the next talk, will be talking about doing that in R and Python. But I'm just going to walk through what that might look like first. So we have a sample experiment where we're trying to predict someone's income level. So in this case, we have census data about various people. And so here we have features such as someone's age. You can see their distribution of their age. What kind of work they do. Are they private, or are they working for the government, or are they doing professional work? Their education, bachelor's, master's, PhD, et cetera. How many years that they've went to school, whether they were married or divorced or single. what their occupation is, what their race is, and their gender, etc. So based on all these features, we're trying to predict how much their income is. Are they going to make less than 50,000 US dollars a year or more than $50,000 US per year? And so in this case, we start out with that question. This is a binary classification question. Do they make less or do they make more than $50,000 a year? So, so in this case, again, we have our data. We're going to clean the missing data. We're going to do projecting. We're going to remove some columns. And then here we do the splitting again. So we want to make sure that we have our training data. That's what we're going to train on. And then we're going to leave some out for testing. So the algorithm we're using here is basically a two-class boosted decision tree. And what a decision tree is, let me just illustrate that with a quick example. A decision tree is just basically an algorithm that helps you at each stage make a decision. So based on your features, you're trying to predict something. So in this example, we're actually going backwards, but we're trying to predict credit risk. So how do I know if someone has good credit or bad credit? So your bank does this all the time. Right? If you go to the bank and you want to make a loan, or if you want to apply for a credit card, the bank wants to know, are you going to pay back the money or not? So what they start out with is maybe they'll look at your income. Do you make less than 15,000 US dollars a year? Oh, then already they know you're high risk. Maybe if you make between 50 and 35,000, okay. Then the next thing they'll look at is your credit history. Do you have bad history? Then you're high risk. You have a good risk history, then maybe moderate risk. Then if you don't have credit history, then they'll look at the amount of debt that you have and see whether you have high risk or moderate risk based on that. Or if you make over 35, again, they'll look at credit history, and then they will determine risk that way. So this is just an example of a decision tree. This is just another algorithm that can be built, that can be trained. So what boosting means is that you'll take different decision trees, take the outcome, and then aggregate the things of the outcome. And so that way, it's just one way of being able to make a better decision. And so here in Azure Machine Learning, all we're doing here is using the algorithm. So the algorithm I just described to you is used here. And so you don't have to worry about that as much. And then you train it, and then you can build a model to determine whether somebody makes more than $50,000 a year or less than $50,000 a year. And so this is just, again, another sample experiment. Just like today we talked about Titanic, where we were predicting someone would survive or not. This is just basically how much money are they going to make. And I'm talking through this example because this is how it's done in Azure Machine Learning, but Seth will talk about later how you can do something like this in R or Python. Okay, so do we have anybody who know R and Python today? Anybody here who does a lot of R and Python? Okay, so a couple of people who do R and Python, perfect. So, so that's just another tool that you can use. But if you don't know R and Python, then you can just do this. And again, we'll do a demo tomorrow, tutorial, where we'll all build an experiment together. And so we'll do that. And so, so with that, that's basically everything I had for this talk. Again, for successful data science, again, as you're thinking about the hackathon, I really encourage you to participate. We have a lot of great prizes, but we have a lot of people who are here to help you. So I would really want you to stay and think about some of the questions that you want to solve, what kind of apps you want to build, or what kind of machine learning models you want to do, or if there's anything that you are currently working on in your company that you want to make a little more intelligent, or you want to attach to a machine learning model, those are great ideas for the hackathon. So I really encourage you to participate. But as you want to think about data science, as you want to think about how to make your apps more intelligent, or how to do more predictive analytics, then the four things is really to know your data, know the data that you have, know your question, what questions you want to ask, knowing your domain, and finally, knowing how you're going to use the answer. So I just want to show you something here too. We have an online course. This is edX, so this is just an online course. This is entirely in English, but Data Science and Machine Learning Essentials. This is a free course. And you got the Azure credit, the Azure Pass today as by coming here. You have some Azure credits, but you can also use Azure Machine Learning for free. So you can follow this course. You can use Azure Machine Learning for free and just learn some of the basics of data science. So I believe that data is really just the next step in terms of the kind of the future wave. We focus a lot on the IoT. We focus a lot on what things are going to be next, what things are going to be hot, because so much more data is being produced now. A lot of data is being born in the cloud. And how do you make sense of all that data? If you don't use machine learning, if you don't use anything to be able to make sense of that data, it's going to be very hard to really think about what you're going to do next. So I really encourage you, if you don't have as much data science knowledge, there's a lot of great resources online, a lot of great resources that are free. So this course is a course that we did in Microsoft. We partner with a professor from MIT and also just some other people to be able to create this course and to be able to teach you how to do more from a data science perspective. So I know this talk is pretty short, but I'll be happy to stay around if you have any questions. But and then Seth will be doing the next section on Python and R. Okay, so thank you very much. Very useful. If you have data like that, you're not going to predict somebody's blood alcohol content, right? But how would you? Okay, maybe in terms of their body mass, if you know how much they weigh, if you know how many alcoholic drinks, margaritas they've drunk, then maybe there's an easier way to be able to predict their blood alcohol content. So it's very, very important to have the relevant data. Sometimes you'll find that data is very disconnected. Maybe you have a data source that's about one thing, and you have another set of data that's from something else. You try to join them together, and you find you have a... So in summary, data science is not magic. You know, sometimes if we don't understand a topic, sometimes we just think it's magic. But really, data science is not magic. But there are some tricks and secrets that might be interesting to think about. So the 4 main points that I'll be covering today in terms of the secrets for data scientists. First is to know your data. It's very important that you have to know your data. Second, know your question. What question are you asking? Know your domain, because you are experts. You know your data. But what I will be speaking about would be data science for the rest of us. So if you're a developer, could you please raise your hand if you think of yourself more of a developer? Okay, so we have a lot of developers here. How about any data scientists? Any data scientists? Okay, good. So we have some data scientists. But this talk is really for helping you think about data science. How does a data scientist think? How do you use data? And then that will help you be able to create a solution that uses data. Know the domain of your data and know how you're going to use the answer. Because sometimes people go and they have a problem and they ask things and they don't even know what they're going to do with the solution. So know how you're going to use your answer. So the first thing that we're going to talk about is know your data. So let's say you wanted to make a pizza, right? Let's say you want to make a pizza. What are some of the things that you need to make a pizza? You probably need flour, you need water, you need cheese, maybe spaghetti, maybe tomato sauce. You know, you need good ingredients, and you need relevant ingredients. The data, just like data, if you don't have the right ingredients, you will not have the right product. So you need data that's relevant, it's connected, it's accurate, and you need enough data. So let's talk about blood alcohol content. So basically, let's try to predict whether somebody is drunk. Okay? How do you predict whether someone is drunk? So irrelevant data on the left here is, let's say your data is the price of milk per gallon, or like the Red Sox batting average. Like, that's not